In this video, we're going to be talking about time series cross-validation. This is just a more sophisticated version of training and test sets and just dealing with forecast accuracy. So let's take a look at what we do in a traditional evaluation, forecast evaluation, before we jump into the time series cross-validation. In our traditional evaluation, we have some training data and some test data. So test data is about 20% of your data set. Your training data is about 80% of your data set. And we use the training data to fit a good model. And then we then forecast H periods ahead and compare our forecast to the test data, right? So that's what we're doing in our traditional forecast evaluation. When it comes to the time series cross-validation, this looks a little bit different. What we do iteratively is that in cross-validation, we use a series of test sets, but each test set contains only a single observation. So in these red dots display the test sets, right? And so you're doing forecasting iteratively in each step. At each point, you're going to add some data to your training sets and use all of the values prior to the red dot, to compute the forecast one step ahead. So each time your training set contains the observations just prior to the test set. Now, when we look at forecast accuracy measures in cross-validation, we typically have some metrics from each iteration. What we do is we average those accuracy metrics over the test sets that we have. So these are all different test sets, right? This point is different than this point, okay, and so on and so forth. So for this reason, this type of method is also known as evaluation on a rolling forecasting origin. This basically suggests that the origin is at which the forecast is based rolls forward in time. Now, creating the rolling training sets, right? You saw that here there is sort of this training set that adds one more value of y each time in each iteration, and we keep moving forward, okay? So the training set in the second iteration is just the training set in the first iteration plus one, okay? And so you keep adding one observation each time. Now there are three main rolling types that can be used. The first one is the most commonly used rolling type window, which is called stretch. When we used the stretching window, this is usually going to extend a growing length window with new data each time in each iteration. The second type is called slide, which shifts a fixed length window through the data with some overlap. And the third is called tile, which moves a fixed length window without overlap. And these are the functions that in the Sybil that allow you to work with stretch, slide, and tile. But before we get into forecasting, I think we can take a look at what those, so here's slide, and here's tile and stretch. So stretch is adding one at a time. If we take a look at this again, tile is using a tile basically that doesn't overlap. and adding the training set or adding data to the training set using a fixed window. And then if we look at slide, it looks like this has some overlap for the training set. So in each iteration that you see, you're increasing the size of your training set. So going back, we can try to just take a look at just the stretching rolling window example to illustrate what's going on with financial data. So let's deal with the Google 2015 data set and create what we call a stretching symbol. Okay, so stretch underscore symbol would create that. So here we're gonna create a new type of training set, which is iteratively going to add one value to the training set. So we will extract the stretch rolling window from the Google underscore 2015 dataset, and we will use the stretch underscore symbol command to do that. So there are two arguments here that you want to pay attention to. The first argument is called .init, which is saying, well, how many initial values of the training data should we start with? So that's equal to 3. So this is saying you will have 3 data points in your training set, or 3 days if you're looking at the stock prices. And then we're saying that in each step or in each iteration, add one value to the training data set. Okay. And then in this last step, we are trying to filter out the outlier here. So we're saying id.id, which is the closing price, is not equal to, filter out all the observations that are not equal to the maximum of this id value, which is removing the outlier. So notice what happens in this output here. So what we see is that we've created this Google underscore 2015 underscore stretch symbol, which has trading days. In the first training set, we have 1, 2, 3 points, because that's what we wanted for our training set. And the ID is 1, 1, 1, right? There's 3 observations here. In the second iteration, we have 4 points here, which is our second iteration. Okay, so 2, 2, 2, 2 represents the 1, 2, 3, 4 points in our training data set. And so the next one would be 1, 2, 3, 4, 5, and 3, 3, 3, 3. 3, yeah, one more 3, so 5. So after you've done that, you can just fit a cross-validation model, and you can choose anything, but we'll just go with a drift model here for this. But make sure you're using the stretching training set that you have here. And we can then produce one step ahead forecasts from all models. Okay, so we have the forecast for using cross-validation is going to be using the fitted model here, and forecast H is equal to 1. Forecast horizon is just 1, remember, for cross-validation. So you're going to have this column right here, which is going to give you your forecasts. Okay, I mean, it's going to give you it's going to tell you what is that forecast associated with, for which day. So obviously, if we started with 3 points in our training set, then the test set is going to be at trading day equal to 4. Okay, so we have our close is going to tell you the forecasts, and then you have the distribution of your forecasts. And here, what we're doing is checking the accuracy of our using our cross-validation technique. So using the accuracy command, we can do that. We can compare this to a test set or a training set. So Training set is not very useful, but we still have it here if you want to look at how to do this. But here you're taking the Google data again, you're putting this through the naive model, and you are testing for accuracy. Now remember, the accuracy that you're measuring here is using the drift model. So maybe you want to keep the same model and compare the training and the cross-validated models. Now you have, again, different columns representing different forecasting metrics, and you have the cross-validation technique, and you are comparing that with the fitted values, or the training data set. And here we see that the training data set outperforms the cross-validation technique, and this is pretty obvious because you have the fitted model based on the entire data set rather than those representing true forecasts. So if you really wanted to compare cross-validation, you would actually compare it to the test set. A good way to choose the best forecasting model is to find the model with the smallest root mean squared error computed using time series cross-validation.